This is a brief demonstration of the interactive figures in PreCalculus algebra. For each figure, there's a page with an explanation and a page with an exploratory exercise. This figure shows that as the X slider is moved, the square cut from each corner gets larger until there's no box when the sides are folded up. As the X values decrease, the box is visible. We can show the dimensions in terms of X, the function in factored form, the volume, and the domain of X, that is between 2 and 10 inclusively for this particular problem. However, when X equals 10 centimeters, the volume is 0. As the X slider is moved, we see the volume of the box changes. By finding the relative maximum of the function within the domain, we determine that the maximum volume of the box is 1,152 cubic centimeters when X equals 4 centimeters. This figure shows the graph of a rational function that has a hole at the point where X equals 1. As the X slider is moved, the point on the curve moves and shows the coordinates of that point. Looking at the equation for the function, we see that the vertical asymptote is X equals -2. We also see that Y equals 0 is the horizontal asymptote. As the sliders for A, B, and C change, the function changes and the graph changes. Finally, we see that the graph may cross the horizontal asymptote. This figure shows 3 functions. The first is an increasing function. By moving the x sub 1 and x sub 2 sliders, we can see the shape of the function. When both x sub 1 and x sub 2 are within the increasing interval of the function, we will show the interval on the x-axis. Also, the function is shown and the functional values are shown. Here we see that the interval is shown where the function's increasing. The second functions are decreasing. The same applies in terms of getting x sub 1 and x sub 2 in the decreasing interval. And the third function is a constant function. When x sub 1 and x sub 2 are within the interval where the function's constant, then the constant interval shows on the x-axis. This figure contains 5 polynomial functions. We'll be using the leading term test for polynomials. The n slider will set the degree. Here we're set to 4. The a slider will set the coefficient of the leading term. In this case, we're going to set it to -1 to compare with the graph that we've given with the function up above. We have the capability of zooming in or zooming out to see better what the graph looks like. Now we're changing the function to a 5th degree, and we need to zoom out here so that we can see that better. Change the g function to a 5th degree to make the comparison. There we can see that the right side goes down, the left side goes up because we have a negative coefficient for the leading term and the exponent, the degree, is odd. Changing that to a 7th degree, we have a positive coefficient, therefore the right side goes up, and since the degree is odd, the left side goes the opposite direction, the left side down. And we can check that with the g function using the leading term. This figure shows 5 functions, 2 polynomial, 1 radical, the greatest integer, and a constant function. By moving the x slider, we can see the functional values while x is in the domain of the function. This figure shows a circle with the equation in the center radius form and the expanded form. Using the radius slider, we can change the size of the circle. The center of the circle can be dragged to move the circle on the grid. We can zoom out for larger circles and show the x and y intercepts. This figure shows four functions, a quadratic, a radical, and two piecewise functions. Moving the x slider from -8 to +8 shows the domain of the function. Moving the y slider from -5 to +5 shows the range of the function. Notice that the domain is shown on the graph on the x-axis. The range of the function is shown with the graph on the y-axis. Both the domain and the range are shown in interval notation. This figure, application, height of a baseball, shows that as the T slider is moved or the animation runs, the baseball moves along the path of the parabola. The domain of the function is shown to be from 0 to 4.5 seconds inclusively. This figure shows an exponential function that can be changed by using the B slider to change the base and the C slider to include a vertical shift. The graphs and equations for the exponential and inverse functions can be shown along with the line y equals x. By moving the x slider, you can move a point x, y on the exponential function and the point y, x on its inverse function that is reflected about the line y equals x. This can go up to base 10 and also include base e. This figure, polynomial inequalities, shows four types of inequalities, shows three polynomial functions, and three rational functions. Shows the graph, shows the cut points or critical values, shows the sign diagram, whether it's positive or negative. As shown by the rational functions, the cut points are where the numerator equals 0 or the denominator equals 0. Here we see the cut points, -3, -1, and 2. And then, of course, the sign and our solution. This figure uses a linear, a fourth-degree polynomial, a logarithmic, and a rational function to illustrate the intermediate value theorem. It would display the graph, equation, functional values, and conclusion. Notice that function d shows inconclusive even though the y values have opposite signs. Can you explain why this is inconclusive? This figure shows the graph and the equation of logarithmic functions with bases up to 10, including base e. The transformations of log functions may be shown by varying the sliders for a, b, c, and d. Notice that the graph goes through the reference point 1, 0 whenever the horizontal shift c is 0 and the vertical shift d is 0. Also, the vertical asymptote is x equals 0 whenever the horizontal shift c is 0.